This is the second part of the article, Chilling Out, Warming Up, How Animals Survive Temperature Extremes, that you are going to watch and follow along today. Throughout the video, it will stop and ask you some questions as well. Yesterday, we read the warm-blooded, cold-blooded section as well as the introduction, which was page 6. Today, we are going to read the generating energy section on page 7. We will talk about the pictures, and we will also read the heating up a cold-blooded elephant section. We will stop today at the top of page 7 when we are done with this section. Make sure you are following along closely and you're listening and paying attention so that you're able to answer the questions throughout the video. Generating energy. Warm-blooded animals require a lot of energy to maintain a constant body temperature. Mammals and birds require much more food and energy than do cold-blooded animals of the same weight. This is because in warm-blooded animals, the heat they lose is proportional to the surface area of their bodies, while the heat they produce is proportional to their mass. This means that larger warm-blooded animals can generate more heat than they lose, and they can keep their body temperature stable more easily. Smaller warm-blooded animals lose heat more quickly, so it is easier to stay warm by being larger. This energy produced by warm-blooded animals mostly comes from food. Food represents stored chemical energy, which is potential energy, which is converted into other forms of energy within the body when the food is metabolized. Metabolism refers to all the chemical reactions in the body. The metabolism of food within the body is often referred to as internal combustion, since the same byproducts are generated as during a typical combustion reaction, carbon dioxide and water. And like combustion reactions, metabolic reactions tend to be exothermic, producing heat. For a warm-blooded animal, food is not just a luxury. It is a matter of life and death. If food is not available for energy, the body's fat is burned. Once fat reserves are used up, death is imminent if a food source is not found. The smaller the warm-blooded animal, the more it must eat, relative to its body size, to keep its internal furnace stoked. That's why most songbirds fly south for the winter. On the other hand, cold-blooded animals require less energy to survive than warm-blooded animals do, because much of the energy that drives their metabolism comes from their surroundings. It is common to see turtles basking in the sun on rocks and logs. They're not trying to get a suntan, but rather are revving up their metabolism. The sun gives them an energy boost. Muscle activity in cold-blooded animals depends on chemical reactions, which run quickly when it is hot and slowly when it is cold, because the reacting molecules move faster when temperature increases. Some reptiles, such as the python, can go a year without eating because they do not use food to produce body heat. And if they lie still, they can use little energy, so they can afford to eat little. Cold-blooded animals have a disadvantage compared to warm-blooded animals. There is a certain temperature below which their metabolism just won't work. The reason is that all chemical reactions slow down as the temperature is lowered, so at low temperatures, all the chemical reactions in an organism slow down. You may notice that few cold-blooded animals are active in the winter, and the farther north you go, the rarer they become. By contrast, warm-blooded animals are present in a wider variety of environments and for a longer part of the year than cold-blooded animals. That's the end of that section. We're going to go back up to page 7, and we are going to read the section entitled Heating Up a Cold-Blooded Elephant. Cold-blooded animals have either an elongated or flat shape, which helps them soak up the sun and get warm when it's hot outside. But why would it take longer for a large animal to warm up? In other words, if an elephant was cold-blooded, what would happen if the elephant was cold and it wanted to warm up? Think of it this way. Imagine you're trying to defrost a steak in your microwave. After a few minutes, the outside is warm, but the inside is still cold or frozen. This would be similar to trying to heat up a cold-blooded elephant. The outside of our cold-blooded elephant would heat up pretty quickly, but it would take forever to absorb enough energy from the environment to heat up the inside. Over here on the right side, we see some pictures of 2 turtles, and it says these turtles just walked out of a pool of cool water. Notice how cold they are. So you can tell from the picture, blue means cold, red means warmer, yellow and green are in between. So they're incredibly cold. Make sure you've paid attention through this section. Make sure you've answered all of the questions, and then we will complete section in part 3 tomorrow.